Hey guys, and welcome back to the YouTube video. In today's video, I'm going to be again teaching you how to create a neural network in Python. You're going to be using the Cypher10 dataset in Python to create a neural network using the TensorFlow module of Python. And I had already gone ahead and created this neural network. One quick disclaimer that I'm going to give before starting out with this video is the neural network that I've created right over here is a neural network that's not the best for performance. So if we want a neural network with a 90% accuracy, this is not the way you're going to be doing it. You're going to be having a bunch of more layers in you. You're going to be having a bunch of more neurons. You're going to be messing with a bunch of more nodes. You're going to be using some convolutionary networks, some kernel sizes, and a bit more advanced things. The reason why I did not do it in that way because I wanted to challenge you guys to do that by yourselves. So that's why. So we are going to be working the Cypher10 dataset and we'll be making a neural network. You guys can just Google out Cypher10 dataset. Just Google out for Cypher10 dataset. Just Google it up. It consists of 60,000 32 by 32 color images in 10 different classes. They are cat, deer, dog, frogs, horse, ships, and trucks. And there are 6,000 images in each class. It's a pretty large data set. It's not something small, so you gotta be working with a good amount of data. So first I will just go ahead and load in the data. To do that, you can just use this simple little command, and again I will link this Google Collaboratory in the description of the video, so you guys can go ahead and check it out. So to load in any data, I will just go ahead and just make the variable data. And one quick thing, I'm sorry I'm interrupting myself, but still, when you open up your Google Collaboratory, just hit runtime and change runtime type. And in hardware accelerator, you need to select GPU. The reason why I'm doing that is because um, the GPUs are pretty fast when working with TensorFlow. Like all of your code will run really quickly, and as this dataset is quite large, we cannot um, use the no GPU. You can also go ahead and use a TPU, but I'm gonna use a GPU. But and it's pretty good. So it will actually speed up your code running quite a bit. I know it says to get most of Colab, we should avoid using that, but I've already worked with and I know the difference. So just loading in the data is pretty simple. All we do is just type out data as equals to chars of dataset stuff Cypher10. That's the dataset that we are working with. Now uh, this is pretty important, and if you guys haven't downloaded the data, just run that cell and it should go ahead and download it for you. And now we just split the data into an X train, Y train, and an X test and Y test, and we'll be loading the data into these four categories. So now if I just run the code, it should do that. Now the class names. Now what are the class names? The class names are the possible predictions that the model we make can predict. So in our case, it can be either be an airplane, an automobile, a bird, a cat, a deer, a dog, a frog, a horse, or turtle. I know there are a lot of class names, but these are the ones that one can predict, and you don't want to miss any one of these, or else your model will act a bit weirdly or won't work. Now we're going to clean up the data. Cleaning up the data is a pretty important step because the data we are using is very large, and also because the size of the data is too large, and even the RGBs and all of that. So that's why. And now we are gonna be making the model. So to do that, we just use the simple char.sequential command. Now here you can see that the input shape that I've given is a 32 by 32, so it's pretty large. It's like 32 by 32 images, which I think Cypher in dataset. So you can see it's like 32 by 32 images, and 3 is given here because of the RGBs. You could convert it to grayscale, but it's pretty difficult and I did not know what to do. So that's why. So then we just made a dense layer. The dense layer is what I has just 358 neurons. I know you can put some more. The activation I went was simple ReLU rectified linear unit. Rectified linear unit is pretty, I say, good for the first dense layer, and it works pretty nicely. Then the second activation layer that I went was Softmax. I tried the other activation layer called Sigmoid, but it did not work out really nicely with my model, and it kind of gave me a bad accuracy. It just got 10% accuracy, so it did not work really well because I don't know why Sigmoid just did not want to work. Then I just compiled the mod with an Atom optimizer and a sparse categorical cross entropy loss. I went with binary cross entropy, I went with categorical cross entropy, I guess, but binary just did not work. It was very bad. It gave me a really horrible accuracy, and the metrics was just accuracy. Then I just gave it 15 epochs, and the batch size, and now I gave it a verbose. The verbose I am gonna go with one. We just compile fit and make predictions. The batch size is basically the amount of images we show the computer every iteration of the epoch. So that's how, like, we don't want to show all of the 60,000 images together, or else the computer can sometimes get confused, and we don't want to do that. So I just gave it a batch size of 500. We could go with a batch size of like 5,000 or 50,000, but that usually leads to a very bad accuracy. And the reason why I went right, even 500 is pretty bad. I should go with something less or more. I don't know. But Bose, I can't explain to you how it works. I'm just gonna show it to you by googling it. So the reason is that it's pretty difficult to explain to you what a Bose is. So you can just Google it up. So then I just showed the data. So now let me just run the code and show it to you. So as I can tell, the prediction was a dog. It actually was a cat. Prediction truck, actual ship, actual ship, prediction ship, actual airplane, prediction deer, actual frog, actual frog, prediction cat, actual automobile, prediction frog, prediction dog, actual cat, prediction automobile, actual automobile. Now I know you won't be doing this, but I just was telling you, just in case you got a really successful model, you can actually go ahead and save the model. So let me just save the model. So saving the model is pretty simple. All we do is just type out the simple keras. To do that, we just type out model.save, and then we can just save it as cipher 10.h5. That's the extension keras use. I feel like it's model.save or keras.model.save. Let me just have a look. It's model.save. So once you have worked with that, you should have a complete ML neural network model kind of thing, which I feel like works pretty nice. So I hope you guys like this. As I told you, I'll link it down below, the collab notebook, so you guys can mess with it and get also some good apps. So that's it for today, guys. I hope you enjoyed the video. If you did, like and subscribe to the channel, and until the next time we meet, bye bye.